So on page 100, this is applications with linear and rational equations. So what you're going to do is do a bunch of story problems. These are the problems you're going to do. Number 7, 8, 9, 11, 12, 13, 15 through 27, odd, 31, 35, 39, and 40. There's a couple of formulas you'll need. The first one is simple interest, and that's interest equals the principal times the rate times time. So principal is your beginning amount. So principal I never can remember if it's AL or LE, but anyways, that's your beginning amount. R is your rate, and T is your time, normally in years. Okay, so that's your interest formula. The other formula you'll need is distance equals rate times time. So I'll go ahead and do some of these problems for you and with you, whatever way you want to think of it. Hopefully with is a better word. So on number 7, it says Rocco borrowed a total of $5,000. So on these story problems, if you write down kind of what the problem says, it will be very helpful for you. So he borrowed $5,000 total from 2 loans. So he's got 2 loans, loan A, loan B, whatever you want to think of them. From loan A, he charged a rate of 3% interest. And the other charged 2.5% simple interest. Both payable after graduation. If the interest he owed after 1 year, so this is time, equals 1 year on both of these. So the total interest is $132.50. So this is total borrowed. Now it says determine the amount of principal for each loan. So think of it this way. The interest from loan A plus the interest from loan B equals the total interest. Interest total. So interest from A is going to be the principal, which we don't know how much he borrowed, but let's say it's X amount. For example, if X were 1,000, 5,000 minus 1,000 would leave 4,000 for the other one. If X were 2,000, 5,000 minus 2,000 would leave 3,000 for the other one. So let's call A X and B is 5,000 minus X. So the interest of A, principal times rate times time, is X multiplied by 0.03 times 1. Interest of B is 5,000 minus X, that's the principal. The rate is 0.025, and the time, again, is 1. The interest total is $132.50. So that's the interest of A. The interest of B equals the total interest. So now I can just multiply. 0.03 times X is 0.03X. 0.025 times 5,000, I'll go to the calculator. So 5,000 times 0.025, enter, is 125. So plus 125 minus 0.025x equals 132.50. So what we did is we distributed that 0.025 to both of those. So now 0.03 minus 0.025 is 0.005x. If I minus the 125 to the other side, I get that is 750. So now I divide each side by 0.005. So I go to my calculator, 7.5 divided by 0.005. That says it's $1,500. So X is 1,500, so this is 5,000 minus 1,500, so that's $3,500. So that's how you're going to do 7, 8, and 9. So we now go to problem number 11, and it's an application involving mixtures. So it says ethanol fuel mixtures have E numbers that indicate the percentage of ethanol in the mixture by volume. For example, E10 is a mixture of 10% ethanol and 90% gasoline. How much E5 should be mixed with 5,000 gallons of E10 to make an E9 mixture? So what we're going to talk about is just the ethanol part. Okay, so we're going to say 5% of so many gallons plus 10% of 5,000 gallons. So I have to add these two together. And this 5% is going to dilute it. And we're going to get a 9% mixture of something. Now I don't know how much of this one, so I can call it X. I know that if I add X to this 5,000, over here I'm going to have X plus 5,000 as my total amount. Okay? So really what we're doing is we're taking, if you think of it as a barrel, 5% of this barrel is ethanol. The other 95% is gas. 10% of this barrel, whoops, more like 10%, is ethanol, and the other 90% is gas. And so when I add them together, it's going to dilute these two because this doesn't have as much ethanol. It has more gas. So when I do the math part on this, I change the percents to a decimal. So I'm going to have 0.05x. 10% of 5,000 is 0.1 of 5,000, so that's 500, equals 0.09x plus 0.09 times 5,000. So 0.09 times 5,000. So it should be 450 plus 450. So we just distributed that. So now we're going to work this out. I'm going to get the x's on one side, so I minus 0.05x from the left. I do the same to the right. And I am going to minus 450 from each side. So what I end up with, 500 minus 450 is 50, equals 0.04x. So now I divide it by 0.04, divide it by 0.04. So 50 divided by 0.04 is 1,250 gallons. So 1,250 gallons of E5. Okay, the next one I will help you with is number 17. It says Darren drives to school in rush hour traffic and averages 32 miles per hour. So from home to school is 32 miles per hour. He returns home in mid-afternoon when there is less traffic and averages 48 miles per hour. So school back to home is 48 miles per hour. What is the distance between his home and school if the total traveling time, so total time is 1 hour and 15 minutes. So what we have is we have a rate problem. So we're supposed to figure out the distance. We know the total time. We know that distance equals rate times time. His distance from home to school is the same as from school to home. So I know that the distance to school equals distance back to home from school, right? So those two distances are equal. So this is the rate to school. So distance equals rate times time. Miles per hour is a rate. So I have 32, and I don't know how long it took, so I'm just going to call this one T. Distance to home, so rate times time. So that's 48 miles per hour. And I don't know how much time it took, but I know it's 1 hour and 15 minutes. So if I think of 15 minutes in terms of an hour, 15 minutes out of 60 is 1/4. So it took him 1.25 hours total, minus whatever this used. So that's how much time he has left. If he took 15 minutes, he has 1 hour. If it took 40 minutes, he has whatever less that is from this. Okay? So whatever time he used to go to school, I go 1 hour and 15 minutes minus that time, and that'll give me the time that he has to go home. So now I have the equation. It's just 32t equals 48 times 1.25, which is 60 minus 48t. So I add 48t over to here. So 60 equals 80t. Divide it by 80, and t equals 0.75 of an hour. So 3/4 of an hour is our time, but we are not after time, we are after distance. So I can plug that into either one of these because that'll give me distance. So I can go 32 times 0.75, and if I do that on my calculator, or however you want to think of it, 32 times 3/4 is 24 miles. This was miles per hour, this was hours. Your hours cancel off and leave you with miles. So this is a application involving rate of work done. Think of this as work. Joel can do one job in 66 seconds. Jason can do one job. His job is running around the track in 60 seconds. So what we do is we say it takes him to do one job. It takes him 66 seconds, for that's Joel. And they're doing it together now. He can do one job in 60 seconds for Jason. So together, how long does it take him to do one job? So now, in order to do this, you have to have common denominators. So I multiply this by 60 and x. So 60x. This one I multiply by 66x. And this one I multiply by 60 and 66. So they now all have common denominators. I know that x cannot equal 0 because that would mess things up. So that's not a possibility. But once I get common denominators, I can scratch that off. So what I have is 60x plus 66x equals 60 times 66, 3960. So if I add these together, I get 126x equals 3960. So I divide it by 126. So I divide my answer by 126, and I get 31.4 seconds. Is how long it takes them to cover or run around the whole track if they're working together. So that's how the work problems go. You say one person can do it in this much time, this person can do it in this much time if they're working together. So we put a plus equals one job in this amount of time. So anything that has the work, you set them up that way. So work on these problems. I will help you when you get back if you're stumped on any, but you should be able to get through a good chunk of them. At least try them all so that when I go to explain it on the board, you can say, I got to here, I got to here, I got stumped here. And that will be helpful for you in understanding how to do this. So good luck, do well.